chapter 6, triangles. This is part 7. Okay. Children, in the previous session, we learned two important theorems. One, well, 6.1, it is very important for board examination. Definitely it will be asked. Alright. And a second is theorem 6.2, which actually is converse of theorem 6.1. Well, its proof is not given in the textbook. So theorem 6.2, the proof to be learned is optional. Alright? Chali. I think so. Theorem 6.1 was easy. And I hope you have already learned. Please learn it. Alright? Watch the video again and see its proof. Alright. Theorem 6.2 was little bit difficult, especially those two steps where we inverse the ratios and then adding one on both sides. Those two steps are very important. Okay? To understand those two steps in a better way, we are going to see one more concept today. It is not given in your textbook, but learning this concept is very useful, children. Okay? So let's see. This new concept we are going to see is called the laws of proportion. Laws of proportion. Alright? Look here. First one. I am not naming it right now. I will write its statement first. If A upon B is equal to C upon D. What does this mean? We are given two equal ratios. In other words, A, B, C, D are in proportion. A, B, C, D are in proportion. If you remember, alright? Sure. Now, that means it is also called proportion. That's why we call this as laws of proportion. Now, I'm going to alter, I'm going to change the position of B and C. B I'm going to take on right hand side and C I'm going to bring it on left hand side. So C will occupy the place of B and B will occupy the place of C. So if A upon B is equal to C upon D, then A upon dash is equal to dash upon D. Children, look here. That C comes down, B goes up on the other side. Alright. What we have done, we changed the places. We changed the places of B and C. Changed means we altered the places. The other word, English word for changed or change means to alter. Children, when you buy a new dress, sometimes this word is used. Correct? Ready-made garment when you buy, if it doesn't fit, then they say we can alter it for you. That means we can change the shape and size. Okay? Fine. So that's why this first one is called law of. From this word alter. Law of alternando. Law of alternando. Alright? It is called law of alternando. We are altering the position. When four numbers are in proportion, we change the position. Yeah, you can do this also. If you want, you can change the position of A and D. So D upon B. If A upon B is equal to C upon D, then D upon B is equal to C upon A. That by the law of alternando you can do this. So you have two equal ratios and you get two new equal ratios. Please try to understand. This is 2 upon 4 and this is 3 upon 6. They are equal, aren't they? Boliye. 2, 6 are 12. 3, 4 are 12. So if this is given, then you can say 2 upon 3 is equal to 4 upon 6. Children, 1 ones are 1 twos are 1 ones are 1 twos are. So value of this two ratio is 0.5. Value of two equal ratios, 1 upon 2 is 0.5. 1 upon 2 is 0.5. Here, 2 twos are 2 threes are. or I may say 4 upon 6. ऐसे ही रहने दो. Are they equal? Yes. 4 3s are 12 and 2 6 are 12. Here 12 equal to 12. वो भी 12 equal to 12 ही आता है. But this if you cancel or if you divide, this is 0.66666. This is also 0.66666. So they are equal. Here this is 0.5. They are equal. But the values change when you alter the position. When you use alternando, the values change. In short, you have two equal ratios. From there, you get two new equal ratios. But they are not equal. Like the property of equal ratios we saw. Infinite equal ratios we can produce from two ratios. When I finish with this laws, I'll come back to that. Okay? So this is called law of invertendo. Sorry. Law of alternando. Law of alternando. Is that clear? Second law. Look at this. If A upon B is equal to C upon D, same. If two equal ratios are given, then children, what is inverse of A upon B? B upon A. Then what is inverse of C upon D? D upon C. So if I make inverse of left hand side, then I also make inverse of right hand side. See that? Then B upon A is equal to D upon C. What we have done? We have taken inverse of both the sides. We have taken inverse of both the sides. Let's see. This is 2 upon 3 and this is 4 upon 6. Are they equal? 6 2s are 12, 4 3s are 12 equal. And the value of each ratio is 0.666. Iski value is 0.666. Right? Or 0.6 bar, 0.6 bar. They are equal. But I make inverse now. Then 3 upon 2 is equal to 6 upon 4. Value changes. This is 1.5. This is also 1.5. So this is 0.6 bar. This is 1.5. So they are all four are not equal. If these two are equal, then from that we get two new. Alright. What we are doing here? Inverse. That's why this law, second law, is called law of invertendo. Law of invertendo, which states that if A, B, C, D are in proportion, or if we have two equal ratios, A upon B equal to C upon D, then B upon A equal to D upon C. This law is called law of invertendo. Alright. Now we come to a very important law. You may take a screenshot or you may pause and please write these two laws of proportion because I am going to remove it right now. Okay? Check. Fine. Alright. As I said, the third law is very interesting. See. If A upon B is equal to C upon D, then very interesting. Look. A upon B is equal to C upon D. Left hand side is equal to right hand side. So by Euclid's property, adding 1 on both sides. Let's add 1 on both sides. 1 upon 1, 1 upon 1. What is the LCM on left hand side? Yesterday finding LCM in that sum was a little bit difficult. But then you don't need to find LCM once you learn this third property. Third law. इसको law कहते हैं. चलिए, LCM of B and 1 is B. That is very easy. B1 za and 1B za. 1 into A plus B into 1 B. Yeah, that is equal to this side. D plus 1 D. LCM 1 za and D za. 1 into C plus 1 into D. Yes, children. They are equal. Because adding 1 is same by Euclid's property. By Euclid's property, what you have done? You have added 1 on both sides. So this new two ratios we get. Alright, look here. 2 upon 4 is equal to 1 upon 2. 2 2s are 4, 4 1s are 4. They are equal. Okay. Then 2 plus 4 upon 4 is equal to 1 plus 2 upon 2. Children, you observe this. A upon B. is equal to C upon D. A upon B is equal to C upon D. So what is done? A plus B. ये ऊपर A है, उसमें add B. Add the denominator. A plus B upon the same denominator is equal to, same thing we do here, C plus D upon D. So by adding one, this is how you get. So no need to add one. Straight away you can think, what is that? If A upon B is equal to C upon D, then A plus B whole upon same B is equal to C plus D whole upon D. In other words, this is numerator, this is denominator. So A upon B is equal to C upon D. Then numerator plus denominator upon denominator is equal to numerator plus denominator upon denominator. Alright, children. Let's check. यहाँ तो that is equal to 0.5 आता है each one. Correct? If you divide 2 by 4, 1 by 2, you get 0.5. Here it will be different. 6 upon 4 and this is 3 upon 2. This will give me 1.5 each. So these values are different. So ये चारों ratio, this two and this two are not equal. Okay. So then, if A upon B is equal to C upon D, then A plus B upon B is equal to C plus D upon D. Children, ये जो पहले वाले दो ratios थे और नए दो ratios आए, उसमें denominators are retained. आप देख सकते हैं denominators same रहे, only the numerator change. So denominator same रहता है इस process में, when you are using this law. Is that clear? Now what is this law called? Very interesting. Law of componendo. Law of componendo. This is called law of componendo. So from two ratios, we get two new ratios. But all four ratios are not equal. Say, this value is 0.5 and this value is 1.5. ये दो की वैल्यू 0.5 है, ये दो की वैल्यू 1.5, या ये दो इक्वल है, ये दो इक्वल है, लेकिन चारों इक्वल नहीं है. They have different value. This is called law of componendo. All right. Fine. Let's see the next, fourth one. All right. If A upon B is equal to C upon D, then let's check. A upon B is equal to C upon D. This time I am subtracting 1 from both sides. Subtracting 1 by Euclid's property. Upon 1 upon 1. What is the LCM of B and 1? B. That is equal. What is the LCM of D and 1? D. Alright. B into what is B? 1. 1 into what is B? B. 1 into A, plus B into, sorry, it's not plus, B, minus. B into 1 is B. Alright. D into 1 is D. 1 into D is D. 1 into C is C. Minus. D into 1 is D. Yeah, these two need equal ratios. Then, A minus B upon B is equal to C minus D upon D. Somewhat similar. Here we add the denominator, here we subtract the denominator because we have subtracted 1 on both sides. By using Euclid's property, you get this. So now we are not going to subtract 1 on both sides. We know how to write now. So if A upon B is equal to C upon D, that means A, B, C, D are in proportion, or A upon B and C upon D are equal ratios, then A minus B upon B is equal to C minus D upon D. Isn't it? This is called law of dividendo. This is called law of dividendo. Alright, check. Would you like to check one? Okay. 4 upon 5 is equal to 8 upon 10. 5 is a 40, 4 tens are 40. So equal. And if you take the value, it is 0.8. Not 0.8. Yeah, 0.8. It is 0.8. Is that clear? Fine. But, isko bhul jao abhi. Then, if 4 upon 5 is equal to 8 upon 10, then 4 minus 5 upon 5 is equal to 8 minus 10 upon 10. If two equal ratios are given, then you can write this. How? By using the law of dividendo for proportionality. Okay, what you got? Minus 1 upon 5. What you got? Minus 2 upon 10. Minus minus becomes plus. And if you find the value, you are getting 0.2. So 0.8 and 0.2 are different. So from these two equal ratios, we get two new equal ratios. But one thing you must observe here as well. B and D, the denominators remains the same. Alright. Now next one is where numerator and denominator both are changing. Let's see. It is the last law, fifth one. If A upon B is equal to C upon D, then children, I'm writing directly. A plus B upon A minus B. ऑर्डर में A पहले ही लिखना है. A plus B ऊपर, नीचे A minus B is always equal to. Can you tell me what will be right hand side? Say correct. C plus D upon C minus D. अभी इस लॉ को क्या कहते हैं? जब ऐड किया we called it componendo. जब सब्ट्रैक्ट किया we called it dividendo. Here addition and subtraction both is done. So first you have added, numerator को दो, न्यूमरेटर में ऐड किया तो कंपोनेंडो, न्यूमरेटर में सब्ट्रैक्ट किया तो डिविडेंडो, न्यूमरेटर में क्या किया? ऐड. सो इट इज कंपोनेंडो. लॉ ऑफ कंपोनेंडो. एंड सब्ट्रैक्ट भी किया सो डिविडेंडो. लॉ ऑफ कंपोनेंडो एंड डिविडेंडो. चिल्ड्रन मैं ऐसे कर दूं तो देन पहले सब्ट्रैक्ट कर दूं a minus b upon a plus b. Both numerator and denominators are changed. Yeah, c minus d upon c plus b. तो ये भी सच है. इस लॉ को क्या कहोगे? न्यूमरेटर में पहले सब्ट्रैक्ट किया, सो लॉ ऑफ, कैन यू गेस? डिविडेंडो एंड कंपोनेंडो. बट वी कैन यूज दिस. ऑलराइट, चेक. नाउ उसको एक एग्जांपल चेक करना है. 1 upon 2 is equal to 3 upon 6. 2 3s are 6, 2 3s are 6, and each value is 0.5. But if I write 1 plus 2 upon 1 minus 2, here 3 plus 6 upon 3 minus 6, then what you are getting? 1 plus 2, 3, 3 upon minus 1. This one, 9 upon minus 3. Minus minus cancels. You can see 3 3s are 9, 1 3s are 9. So it's same. And answer is 3.0. These two equal ratios is equal to 3. And here the equal ratios were 0. So from two equal ratios, you got two new equal ratios, but the value is different. Is that clear? So these are the 5 laws of proportion. First one, law of alternando. Second, law of invertendo. Third, law of componendo. Fourth, law of dividendo. And fifth, the law of componendo and dividendo. Or if you use minus first, law of dividendo and componendo. Right? Now the monsoon has said, gilli dando must have started in your streets. Do you play gilli danda? So remember gilli danda and this all dandos. Right? So what is the first law of proportion? Alternando. Second, invertendo. Inverse करते हैं. Third, componendo. सिर्फ ऐड करते हैं. Denominator सेम रहता है. Dividendo, fourth one, सिर्फ सब्ट्रैक्ट करते हैं और डिनोमिनेटर सेम रहते हैं. Here fifth, componendo and dividendo. पहले componendo पहला तो ऊपर प्लस और नीचे माइनस. And numerator denominator both change. Is that clear to you? These are the 5 laws of proportion. Children, as I said, let's recall that property of equal ratios. Property of equal ratios. ये laws of proportion है. And how many laws are there? 5. Now properties of equal ratio is just 1. Let's see that. Okay. Say this. 1 upon 2 is equal to 2 upon 4. सही है ना? 1 upon 2. 1 4s are 4, 2 2s are 4, so they are equal ratios. if these two ratios are equal, then I'm going to add 1 plus 2 upon 2 plus 4. Sum of numerator upon sum of denominator. I produce the third ratio, that is 3 upon 6. Or 3 ones are 3 twos are. That is also 1 upon 2. So here you can say that is 3 upon 6. How did you get? By adding. Or let me write like this. Okay, I am writing this 3 upon 6. Alright. How did you get that? Numerator 1 plus 2 and denominator 2 plus 4. And they are equal. ये भी 1 upon 2, ये भी 1 upon 2 और ये भी 1 upon 2 ही निकला. If you want, you can subtract. 1 minus 2 upon 2 minus 4. This is minus 1, this is minus 2. Minus minus becomes plus. So this is also equal. This is also equal. Okay, let me write in this form only so that you understand better. Is equal to. ये भी 1 upon 2 ही आया. So 1 minus 2 upon 2 minus 4. Is that clear? सर आप तो बोलते थे कि इनफाइनाइट इक्वल रेशियोज मिलते हैं, आपको तो 4 ही मिला. अरे बाबा, अब ये तीनों को ऐड करो, ये तीनों को ऐड करो. दैट इज इक्वल टू 1 plus 2 plus 1 plus 2 upon 2 plus 4 plus 2 plus 4. ये भी इक्वल ही होगा. देख लीजिए 6 टोटल और ये 12. 6 ones are 6 twos are. है कि नहीं इक्वल? सो आपको फर्स्ट 2 ही थे आपके पास, तीसरा मिला, चौथा मिला, पांचवा मिला, आपको और आगे मिल सकता है. आई विल शो यू. सी प्लीज, आई विल शो यू कैसे यू गेट इनफाइनाइट. ये भी आप लिख लेना वापस. ये लॉज ऑफ प्रपोर्शन था. नाउ दिस इज प्रॉपर्टी ऑफ equal ratios. Property of equal ratios. And here is the property. If A upon B is equal to C upon D, then each ratio is equal to ये दो रेशियो है, उसको इक्वल था. बोलो A plus C upon B plus D. और कोई और भी ले सकते हैं. A minus B upon B minus A minus C upon B minus D. और अब देखो मैं क्या कर रहा हूं. What I am doing? I am multiplying this by n and this by n. Multiplying first ratio, multiplying and dividing by m. The second ratio I am multiplying. M cancel and n cancel. So A upon B equal to C upon D. But to produce new ratio, after multiplying using this property, MA plus NC upon MB plus ND. So this is again new ratio. आपने यहां मल्टीप्लाई किया, यहां नहीं किया, so you get new ratio. MA plus C upon BM plus D. आपने यहां मल्टीप्लाई नहीं किया, यहां किया, so you get another ratio. A plus NC upon B plus ND. आपने यहाँ M by M डिवाइड किया, M डिवाइड by N किया. Alright, you can divide X divide by X, you can divide 5 divide by 5. Okay, you can here take 7 divide by 7, you can take 9 divide by 9. फिर you use this property, so you are getting infinite equal ratios. You may write that as A upon B is equal to C upon D is equal to A plus C upon B plus D. Sum of numerator is equal to. Here they are all equal. In laws of proportion they are not equal. From 2 you get 2 new, but all 4 are not equal. Here from 2 you get third, from 2 you get fourth, or from 2 you get fifth, and all these 5 or infinite ratios are equal. Right. Now next one is A minus C upon B minus D. That is equal. That's why we have written each ratio is equal to. So they are all equal. That is equal to MA plus NC upon MB plus ND is equal to MA plus C upon BM plus D is equal to. Baba, you get infinite. So this is by the property of equal ratios. I hope you understood. Alright, fine. Let's recall how those 2 steps which you found yesterday difficult, today you will find it little bit easier. Well, we saw theorem 6.1 and theorem 6.2. Here no proof is given in the book, but we prove for our practice. So preparing this for examination is optional. If you want, you prepare. If you don't want, you don't prepare. But this is very important. It is asked in the board examination. Alright? And what was the theorem? Say suppose in a triangle, one line is drawn which is parallel to a side. I'll change the name today. PQR. Triangle PQR. Line L is such that it is parallel to QR, and the remaining two sides PQ and PR, it intersects in point M and N. Then what do you have? PM upon QM is equal to PN upon NR. This line divides side PQ and PR in same ratio, in same proportion. Is that clear? That was there. And if you remember, we used this trick. We took PM base and the vertex opposite to that N. So the red triangle. From N, if you drop perpendicular, this is the altitude. Here I'll have to say NA. NA is the altitude. Alright. Then we picked up this. We thought of this QM. Now this is QM. The third vertex we again choose N only and complete the triangle. Now this is acute angle, this is obtuse angle. Correct? So here from this vertex the altitude is same, this one only. So NA is altitude corresponding to base PM, and this is corresponding to base MQ in this triangle. Then we find the area of this triangle, red and green. Result 1 and 2. And then we take area by result 1 and 2. From result 1 and 2 we use Euclid's property. So this upon this. Alright. Same way. We take PN here. So triangle this one. And then down you have NR. So this triangle, this will be the altitude MB. And it is the altitude of same. We find area of this triangle. We find area of this triangle. Correct? This triangle. Alright. And then we get this. And then you know that's very easy how we used to do. Okay. Fine. What was the other theorem? 6.2. It is converse. Actually, it is converse of theorem 6.1. Now look here. Here one triangle is given, ABC. There is a line intersecting two sides in point D and E. It intersects two sides. But the intersection of line L in two sides at point D and E is such that AD upon BD is equal to AE upon EC. That means line divides the two sides, the line intersecting the two sides divides the two sides in same ratio, same proportion. Then this line L is parallel to BC. In this case, line L is already parallel. Then ratios are equal. Here, line is not parallel, but line divides the two sides in same ratio. Then that line has to be parallel. Let's recall that step, children, please. Please. And see how easy you will find it. But as I said, this is optional. If you want to prepare, you prepare. But please understand it well. And if you prepare, it is always good. Okay. Now, L, we have to prove L is parallel to BC, है ना? We suppose L is not parallel to BC. This line L, it's not parallel to BC. Then there exists another line passing through D. Then there exists at least one line passing through what? Point D and parallel to BC. And that line is this. Today I will take like this, no problem. And that line is this, i.e. M is parallel to BC. That other line I called it M. And it is already intersecting AB in point D, and it will intersect AC also. Let's say in point E dash. Let M intersect AC in point E dash. Alright. Now my aim, because you have already seen, is to show AE equal to AE dash. This is what I am aiming at. AE equal to AE dash. That means E and E dash. I have explained this yesterday. E and E dash. They are in the same direction from A and at equal distance. Then you can say E equal to E dash. अरे बाबा, AE और AE dash equal तभी होंगे जब E और E dash one and the same point होगा, common point होगा. Are you getting me? Fine. अभी ये हमारा टारगेट है to prove this. फाइनल टारगेट तो ये है, but before that we'll have to prove this. और उसके लिए हमने क्या किया था? Yes. Well, it is all okay. This is proof. AD upon BD is equal to AE upon EC. This is already given. AB upon BD is equal to AE upon EC. Result 1 by data. Data में दिया ही है, right? But line L हमने अभी line M को parallel बोला. All right. This one. So, yeah, I'll call it 1 and this I'm going to call it 2. But by 1, it follows that. By 1, it follows that. अरे, line M is parallel. So, AD upon BD is equal to, here it intersects in E dash, AE dash upon E dash C. AE dash upon E dash C. And this is result 3. Now you look at the left hand side of these two results. AB upon BD, AB upon BD. So using Euclid's property in 2 and 3, I'm not writing that. You can say AE upon EC is equal to AE dash upon E dash C. Alright. Left hand sides are equal, so right hand sides are equal. Before that you have to write one statement. Using Euclid's property in 2 and 3 gives AE upon EC is equal to A dash upon EC. Our aim is to show these two are equal. AE equal to AE dash. That is what we aim at. यहाँ तो EC आया और E dash C आया. ECA or E dash C. They are different. So you cannot cancel. Alright. Now see. Now recall the property of invertendo. AE and E dash are to be retained. वो रहने चाहिए. वो change नहीं होने चाहिए. So if I use componendo, AE plus EC upon EC is equal to AE dash plus E dash C upon EC. E dash C. So EC और E dash C रह जाएंगे और जो हमें चाहिए वो बदल जाएगा. What we want is this, but it will change if you use componendo. And this remains. So first we do invertendo. Therefore, EC upon AE is equal to E dash C upon AE dash. How did you get this? You may write this. Invertendo, aap likho. Now componendo. See now, AE and AE dash, they are as denominators. So they will remain, they won't change. But numerator will change. Therefore, EC plus AE upon AE is equal to E dash C plus AE dash upon AE dash. Alright. Now look what change has taken place in numerator. EC, this EC plus AE, this is AE. Well, what is AE plus EC? Yes, it is AC. So up in the numerator, I'll remove this part. Yes. So up in the numerator, EC plus AE is AC. Upon denominator is retained, AE is equal to here. Now E dash C. This is E dash and this is C. E dash C, so much. AE dash. A is here and E dash is here. This one. AE dash plus E dash C. That is also AC. Upon denominator remains the same. Hey children, numerator got same. So cancel. Then again invertendo. I didn't write here. I used componendo. Now 1 upon AE, uska inverse AE. So यहाँ भी inverse करो 1 upon AE dash, uska inverse AE dash. You may write invertendo. Right? So you got AE equal to AE dash. AE equal to AE dash. Are you getting me? Therefore, E is equal to E dash. Therefore, E equal to E dash. I'll write the reason because A, E, C. A dash, E dash C and A dash, E dash C. A dash, A dash, E dash C and A dash, E dash C. That is the reason. Or you can say, if you don't want to write this, it's okay. I have explained to you yesterday. Now, that M is parallel to BC. M is parallel to BC. We have taken that. M का पूरा नाम लिखो. DE dash. Therefore, अथवा IE, DE dash is parallel to BC. लाइन M का दूसरा नाम D और E dash दोनों पॉइंट है उसके ऊपर. So DE dash. I'll call this as result number जो भी आया 4. Result number 4. Okay. Therefore, लेकिन what is E dash? E. So E dash की जगह पे आप लिखो DE. E dash की जगह पे E लिखो. Is parallel to BC by 4. अब देखो D और E, which is the line passing through that L. Therefore, L is parallel to BC. I hope you have understood this. Sure? 100%. Fine. Here is illustration 1. That is example 1 in the textbook. Alright? What it states. Let's prove it. If a line intersects sides AB and AC of triangle ABC at D and E respectively, and E is parallel to BC, that line is parallel to BC, prove that AD upon AB is equal to AE upon AC. Let's see. You are given triangle ABC. So let me draw this triangle ABC. Alright. A line intersects two sides and it is parallel to third side. Let's say this is the line L. This is line L which intersects AB and AC and parallel to BC at point D and E respectively. Correct? It is parallel to BC. It's given. Then, okay, this is statement of theorem 6.1 only, where you got AD upon BD is equal to AE upon EC. AD upon BD is equal to AE upon EC. मतलब आपके पास ये रिजल्ट है. In this situation, in this condition, all the conditions that are given, you have this result. You can say AD upon BD is equal to AE upon EC by theorem 6.1. है क्या नहीं? लेकिन वो नहीं प्रूव करना है. प्रूव क्या करना है? Let's see nicely. Check out. AD वो तो ठीक है. AD upon AB. अरे ये वाला उसी का corresponding side. AD upon AB is equal to AE upon AC. Part upon whole is equal to part upon whole. That is what you have to prove. Children, very easy. Very easy. How you can prove that? Please pay attention. चलिए, data and to prove. Okay, I'll write here. Data and to prove. I'll just pick out what is data. Line L in triangle ABC. In triangle ABC, line L is parallel to BC and it intersects AB and AC respectively in point D and E. To prove AD upon AB is equal to, okay, that what to prove, that I am writing here. To prove AD upon AB is equal to AE upon AC. This is what you have to prove. So now I can just remove this statement and use that space for the proof because the board is little bit smaller. Now please pay attention. Proof. Should I start from here? Proof. All right. In triangle ABC, L is parallel to BC and L intersects AB and AC in points D and E respectively. How did you get this? By data. This is what you have in the data. Therefore, AD upon BD, AD upon BD is equal to AE upon EC. Alright, by theorem 6.1. Alright children, look, आपका AD और AE, AD और AE, they are already there. लेकिन denominators are missing. AB और AC नहीं है, ये तो BD और EC. मतलब आपको BD को AB में कन्वर्ट करना होगा और EC को AC में कन्वर्ट करना होगा. वो कैसे? वो चेंज कैसे लाते हैं? By using componendo or dividendo. But when you use componendo or dividendo, see that what you want is AD and AE. वो तो चाहिए ना, वो denominator में होना चाहिए, है ना? That only it will be written. So first I use invertendo. Therefore, BD upon AD, inverse of this is equal to inverse of this, EC upon AE. How did you get this? Invertendo. We won't write the law of proportion. We'll write invertendo. Now you can use componendo. आप add करो. क्योंकि BD is a part, ये BD जो है वो part है और AD भी part है, और part plus part करेंगे तो whole मिलेगा ना. This part plus this part. All right. So BD plus AD whole upon AD is equal to EC plus AE whole upon AE. What you have used? Componendo. Now look in the figure. What is BD plus AD whole AB? So this is AB upon AD is equal to, what is EC? This EC plus AE, AC. So that is AC. This one is AC upon AE. Because A dash D dash B, A dash D dash B, that's why AD plus BD is AB. and A dash E dash C. A dash E dash C. That's why you can say AE plus EC is equal to AC. Children, ये तो उल्टा हो गया. AD और AE ऊपर चाहिए, ये तो नीचे है. So once again invertendo. Therefore AD upon AB is equal to AE upon AC. We used invertendo again. Invertendo. And this result is proved. Proved. Got it? But one thing I would like to say, children, if this question is of 2 marks, you may write directly by theorem 6.1. But if same question is asked as a 4 marks question, then first you prove this. मतलब theorem 6.1 पूरा till you get this लिख लो and then you proceed. क्योंकि उसके बाद तो 1, 2, 3 और 4 ही steps है after that. So if this question is in the form of 2 marks question, you may write this directly by theorem. If you don't remember the number, don't worry, just say by theorem. And if you remember, it's well and good. Chapter 6 में से है और the very first theorem, so 6.1. And after that, but if it is 4 marks, पूरा theorem 6.1 जो हमने ये यहाँ ट्राइंगल लिया, ये ट्राइंगल लिया, फिर ये और ये लिया, पूरा theorem प्रूव करो. प्रूफ के एंड में आपको ये मिलेगा. And then you continue. Then you will get full 4 marks. Is that clear to you? Sure? Understood? Fine. All right, children. Suppose you had to prove this. AD upon AB नहीं. Instead of AD, see, AD is a part of this side, part upon whole side, part upon whole side. But we have 2 parts in the lower half plane of line L. L के नीचे ऊपर AD और AE है, तो वो प्रूव किया. अब ये भी प्रूव कर सकते हैं. BD, the part in the lower half plane, BD upon AB is equal to EC upon AB. ये भी प्रूव कर सकते हैं. उसके लिए बहुत आसान. Children, you don't need to do invertendo. आपको invertendo करने की जरूरत नहीं है. क्यों? क्योंकि आपका BD और EC आ गया. ये BD और EC तो आ गया यहाँ और वो डिनोमिनेटर में ही है. It's in the denominator, so there is no need to make invertendo. Straight away you can go for componendo. Therefore, क्योंकि you have to change. ये AB और AC नहीं आया है, उसके जगह पे AD और AE है. So you will have to change the numerators. For that you can use componendo or dividendo. Here part plus part करना है, क्योंकि जो AB है its whole, AC है its whole और यहाँ AD और AE पार्ट है, तो पार्ट को होल करना हो तो उसमें कुछ ऐड करना पड़ेगा. So we are going to use componendo. AD plus BD upon BD is equal to AE plus EC upon EC. We have used componendo. Now we have already seen AD plus BD is what? AC. Therefore, upon BD. AE plus EC is what? AC upon EC. This is AB. AD plus BD is AB. Because A dash D dash C and A dash E dash C is here and B is here. Alright. Children, sir, BD EC नीचे आया और AB AC ऊपर आया. अरे भाई इन्वर्टेंडो यूज कर दो, so you get the result. Therefore, BD upon AB is equal to EC upon AC. Invertendo. So, proved. Children, I am going to compile all this. So, by theorem 6.1, you get one result, which is AD upon BD is equal to AE upon EC. Result number 1. Now, by illustration 2, illustration 1, what we get? AD part upon AB is equal to AE part upon corresponding side AC. Result 2. उसी में से one more result. BD upon AB is equal to EC upon AC. So 3 result मिले same condition में. If line intersects 2 sides and is parallel to third side, then you get 3 results. There are, children, 2 more results, so totally 5 results. So let's see that also. So let's see. Now here, this line L is parallel to BC, correct? So recall children, when you have parallel lines, you have a transversal. Then these two angles are alternate pairs, so they are equal. So suppose these are parallel, the transversal is somewhat like this. Then these two angles are corresponding angles, so they are equal. So here you can imagine line L and line BC are parallel and BD is transversal, so angle B is equal to angle D. Same way, line L is parallel to line BC and EC is transversal, so angle E is equal to angle C because they are alternate pairs. Are you getting me? Correct. So here I am going to pick up two triangles. First triangle is ADE and the second triangle is ABC, green and blue triangle. In green triangle, angle ADE is equal to blue angle ABC. Am I right? Angle ABC. Reason? Corresponding angles. Corresponding angles. Children, लेकिन आप बोलेंगे सर यहाँ तो एंगल ADE था और यहाँ तो एंगल DBC था, तो how can you say ABC? DBC angle or ABC angle are one and the same. But what is the reason? A dash D dash B. So I am writing that also. A dash D dash B. Because we have used angle ADE, green one. That is okay. But angle ABC we have written for angle DBC because of betweenness. Same way. Here, which angle? AED. Angle AED is equal to angle ECB. But I can write directly ACB. Blue angle ACB. The same reason. Corresponding angles. And here it is A dash E dash C. A dash E dash C. Children, green triangle or blue triangle के बीच two corresponding angles are equal. So by AA criterion, green triangle is similar to blue triangle. Therefore, a correspondence. ग्रीन का मैं लिख देता हूं चिल्ड्रन. ग्रीन का कैसे लिखूं? ADE लिखूं. ADE corresponds to dash dash dash. ब्लू का डायरेक्ट नहीं लिख पाओगे. Is a similarity by AA criterion. All right. You must write similarity full word. I am using shortcuts. All right. Children, how will you write this on right hand side of this line? Arrow, both sided arrow. How will you write that? You have learned. Yeah, if any angles are there, you get direct correspondence. ये तो full name है angle का. This is full name of angle. So आपको center पकड़ना पड़ेगा. D corresponds to B. D vertex of green triangle corresponds to B vertex of blue triangle. D is in the center, so B will come in the center. Next, E corresponds to C. E is last, so C has to be last. And blue triangle में B और C आ गया. Fill in the blank by A. Fill in the blank by A. Is a similarity. Proved हो गया? अरे, this correspondence is similarity. So you have three equal ratios. AD upon AB is equal to DE upon BC is equal to AE upon AC. AE upon AC. अगले वाले रेशियो में ये था, याद करो पहला by theorem 6.1. AD upon BD is equal to AE upon EC. Part upon part. इज इक्वल टू पार्ट अपॉन पार्ट. फिर इलस्ट्रेशन 1 में पार्ट अपॉन होल इज इक्वल टू पार्ट अपॉन होल. होल में ए बी साइड और AC साइड इन्वॉल्व है. और थर्ड रिजल्ट पार्ट अपॉन होल इज इक्वल टू पार्ट अपॉन होल, सॉरी पार्ट अपॉन होल. ऑलराइट, अब देखो AB इज होल साइड, AC इज होल साइड, BC का तो कुछ है ही नहीं यहां, तो मैंने उसको निकाल दिया. इज दैट क्लियर? इज दैट क्लियर? और उसको भी रखो, वही तो चाहिए हमें एक्चुअली, DE अपॉन BC. बट चिल्ड्रन यहां मुझे मिला AD अपॉन AB, दिस AD अपॉन AB. वहां रिजल्ट है AE अपॉन AC, है ना? बट आई एम गेटिंग दिस नाउ फ्रॉम दिस सिमिलैरिटी, AD अपॉन AB इज इक्वल टू DE अपॉन BC. उसी तरह दिस इज रिजल्ट नंबर 4, AD अपॉन AB इज इक्वल टू AE अपॉन AC. वो है. नाउ आई गॉट AD अपॉन AB is equal to DE upon BC. Same way, AE, this also you can take like this now. AE upon AC. AE upon AC is equal to what? DE upon BC. So ये चौथा रिजल्ट, ये पांचवा रिजल्ट. Let us compile all 5 results together and see. Okay? Let's see. Children, this is the situation. You have triangle ABC and you have a line parallel to one side intersecting the remaining two sides in two distinct points D and E. Correct? Result 1 that you have, AD upon BD is equal to AE upon EC. AD upon BD is equal to AE upon EC. This you got by theorem 6.1. Second and third result, AD upon whole is equal to AE upon whole. AD upon AB is equal to AE upon AC. Third, in third, this part upon whole is equal to this part upon whole. That is BD upon AB is equal to EC upon AC. This both you got in illustration 1, example 1. So we say by result. When you use this, you say by result, the result that we prove. Okay? And 2 more. I'll write here 4 and 5. That by AA corollary. By AA corollary, what you got? Thus, AD upon BD, AD upon BD is equal to DE upon BC, is equal to DE upon BC. And fifth children, same. AD, sorry, now this side actually, this side. AE upon AC, AE upon AC is equal to same DE upon BC, DE upon BC. So these are the 5 results you get in the same situation, same condition. What condition we have? A line is parallel to one side of a triangle, it intersects the other two sides. Alright, in distinct points D and E. Then we have 5 results. AD upon BD equal to AE upon EC by theorem 6.1. AD upon AB is equal to AE upon AC. By result, BD upon AB is equal to EC upon AC by result. Now this, आपको ये वर्टेक्स में से ही लेना है, ये 2 रिजल्ट. ये पार्ट नहीं लेना है, BD पार्ट नहीं लेना है, ऊपर वाला पार्ट ही लेना है पर हाफ प्लेन में. AD upon AB is equal to DE upon BC. Same with this side, AE upon whole part AC is equal to DE upon BC. I hope you understood this. All right. So we finished the session today here, and please see, revise nicely. All right. So that's all for today. Goodbye.